Let's solve this system of rational equations. Now, the first thing we're going to do is set these equal to each other. All right, they both equal y, so they equal each other. So that gives me x over x plus 5 is equal to negative 25 over, let's go ahead and factor this now so we can see what we're dealing with. X squared is x times x. 10 is 2 times 5. Inner plus outer equals middle. Inner, I have 2x. Outer, I have 5x. To get a positive 3, I need a negative 2 and a positive 5. So negative and a positive. A negative times a positive is a negative for the negative 10. So this is working out great. Meanwhile, we have 5 and then x minus 2 here. Let's go ahead and mention what the excluded values are now that we have the denominator all factored out. Looking at the x plus 5, we know that x cannot equal negative 5. Can't divide by 0. Looking at the x minus 2, we know that x cannot equal positive 2. So these are the excluded values. Now our strategy will be to make the denominators the same and then cancel out those denominators. So this denominator has x plus 5 and x minus 2. So if I give this denominator x minus 2 factor, now they're the same. That's legal as long as I do the same thing to the numerator. Now, to make this denominator match, it needs an x plus 5. So we'll have to put that in the numerator as well. Now my denominators are all the same. Once they're the same, you can cancel those denominators out and make a new equation using the numerators. I'm going to go ahead and distribute this. So that's x squared minus 2x is equal to negative 25 plus, and I'm going to distribute this as well, 5x plus 25. So it's just a matter of solving this. So I've got x squared minus 2x is equal to 5x. Now negative 25 and positive 25, they just cancel each other out. So I'm just bringing down the 5x. I am going to subtract 5x from both sides. So now I have x squared minus 7x is equal to 0. Now I see the GCF here. We've got a common factor of x, so this becomes x times x minus 7. And setting both of these equal to 0, I have x equals 0 and x equals 7. So these will be my solutions as long as they are not excluded. My excluded values are negative 5 and 2. Neither of these are excluded, so these are my solutions to problem number 1. All right. Oh, wait. We're not finished. Got carried away. These are not the final answers because this was not a normal equation. This is a system of equations. So instead of just finding x, I have to be careful to make sure to find y as well. All right, that's the difference between solving a system of two separate equations as opposed to just solving a single equation. So we're not done. We need to find the y values. Let's see. I'm going to switch colors. Let's go purple. So it's sort of like this. We have these two x values, 0 and 7. but we need the y values that go with them. You can use either one of these two equations over here. This one seems simpler, so I'm going to use that. Y equals x over x plus 5. So I can either use a calculator or do it by hand. So this is simple enough, and these x values are simple enough that it's probably easiest just to do it by hand. If I take 0 and put it in for these x's, then that's 0 over 0 plus 5. That gives me 0 over 5, which is 0. Okay, so 0 comma 0. Now, how about if I put in 7? Then that would be 7 over 7 plus 5. That's 7 over 12. And nothing I can do with that. So that would be the answer, 7 over 12. So my final answers are 0 comma 0 and 7 comma 7 twelfths. So these are my final answers. So it's not just 0 and 7, it's 0 comma 0 and 7 comma 7 twelfths. Phew, that was close. Now look at problem number 2. This problem looks way simpler. Setting these equal to each other like you do. So I have 1 over 3x equals 2x plus 5. Now would be a fine time to mention the excluded values. X cannot equal 0. Alright, my only denominator here is 3x. If I set that equal to 0, I get x equals 0. So x cannot equal 0. So now let's keep going and make all the denominators the same. So I see the 3x, so I want this denominator to also have 3x, which I can do as long as I put 3x in the numerator as well. Once you have the like denominators, you can cancel them out and make a new equation using the numerators. So I have 1 equals, and I distribute here. So that'll be 6x squared plus 15x. I'm going to subtract this 1 from both sides, so I've got 0 equals 6x squared plus 15x minus 1. Okay, this will probably factor, but if it doesn't, there's always the quadratic formula. So it's either going to be 2 times 3 or 6 times 1. Let's try the 2 and 3 first. So say if I do 2x and 3x. Now 1 can only be 1 and 1. This is not going to do it. Inner plus outer must equal middle. Inner, I have 3x. Outer, I have 2x. There's no way to get 15 out of that. So I'm starting to wonder if this is factorable at all. So I'm going to try 6x and x. This is not going to work either. Inner, I have x. Outer, I have 6x. That's not going to get me to 15. That means I'm going to have to use the quadratic formula. Alright, the first thing we do for the quadratic formula is we figure out what's b squared minus 4ac. So in this case, that is 15 squared minus 4 times 6 times negative 1. Because this is a, this is b, and this is c. So b squared minus 4ac. Okay, so what was that again? 25 squared minus 4 times something times something. Did I say 25? Ha! I messed up. 4, 6. Okay, so 249 is the discriminant. Okay, so now when I do the rest of the quadratic formula, that's going to be opposite of b, which will be negative 15, plus or minus square root, all over 2a, and a is 6, so 2a will be 12. I'll just go ahead and put 12. Now, of course, under the radical goes the discriminant, which is 249. So now I can go ahead and just do the rest of this. I don't think this simplifies. Let's see what the square root of 249 is. See if it's just a random decimal. Yeah, that doesn't simplify at all. So in that case, let's just go ahead and do this. So what I have is negative 15 plus the square root of 249 over 12. And I have negative 15 minus the square root of 249 over 12. These are my two answers. I'm just splitting up the plus and the minus. So we're getting decimals here, guys. That's what's happening. Okay, so here we go. So what was it? Negative 15 plus the square root of 249 over 12. All right, ignore this. Toggle it. Let's go ahead and use a bunch of decimals. Okay, I'm going to use, I'm going to go all the way to here. So this is 0.0649. So that's 0.065. Okay, now let's do the other one. Now if I want to, I can save myself a little bit of time. If I go back to here, edit, I can just jump up there and switch that plus to a minus. Alright, ignore that and just toggle it. So I have negative 2.565. Okay, I'm going to round that up right there. So negative 2.565. Okay, so these are my x values. So be careful, wonderful children, fine students, because this is a system of two equations. So we're not going to just stop at these x values. Oh no, we need to find the y values as well. So my x values are 0.065 and negative 2.565. But I need those y values, guys. Need them. So let's use this equation right here. It doesn't matter which one of these we use. Just pick one. Because of all the decimals, I'm definitely going to use the calculator. So table function, type it in. So it's 2x plus 5. So 2x plus 5. Boom. Make sure your calculator is in Ask X mode. Okay, so I want to evaluate at 0.065. Okay, that's 5.13. And I want to evaluate at negative 2.565. That's negative 0.13. Alright, so there you go. These are the solutions to this equation. So my final answers are 0.065 comma 5.13 and negative 2.565 comma negative 0.13. These are the two solutions to the equation. Alright, so that's it for number 2. Alright, number 3. Let's set these two equations equal to each other. So that means I'm going to have the top equation, which is 4, then I got this 5, and that's equal to x plus 4. So I'm setting these equal to each other, but I'm going to factor this. So x squared minus 16, that's x plus 4 times x minus 4. And then, alright, I've got the x plus 4 here. And again, with the x squared minus 16, x plus 4, x minus 4. Now is a good time to say the excluded values. X cannot equal, looking at the x plus 4, x cannot equal negative 4. Looking at the x minus 4, x cannot equal positive 4. Okay, so let's make sure that none of our solutions turn out to be either of these. Now, our strategy will be to make the denominators the same and then cancel them out. So all of the denominators have x plus 4. Now these denominators have x minus 4 as well, except for this one. So if we give this denominator a factor of x minus 4, now they will all be the same. Now I can't just do that unless I do the same thing to the numerator. Now all the denominators are the same. So I can cancel out the denominators and make a new equation out of the numerators. So I have 4 plus, going to distribute this, so that'll be 5x minus 20 is equal to x plus 4. Combining these like terms, I have 5x minus 16, alright, with the 4 and the negative 20 is negative 16, is equal to x plus 4. Now I will subtract x from both sides, so that'll be 4x minus 16 equals 4. Now time to add 16 to both sides. So that will give me 4x is equal to 20. Then if I divide both sides by 4, I get x equals 5. Now be careful. This is a system of equations. I have two equations. I need to find not only x, but y. I need the y values. So do not stop here. Keep going. Got to keep going. So basically it's like this. If you think about having an xy chart, I have the 5, but I need the y value to go with it. I can use either one of these two original equations to find this y value. This is sufficiently complex that I am going to use my calculator to help me. So table feature, what was this, x plus 4 up here, and then I believe we had x squared minus 16 down here. Okay, so that is what is happening. Okay, so let's evaluate. Make sure your calculator is in Ask X mode. And I'm just going to delete this. It's a little distracting. Alright, we want to evaluate at 5. So, bling, 1. So the answer is 5, comma 1. Alright, and notice that that 5 is not one of the excluded values, so we're good. We're real good. Alright, we have one more problem to do. Problem number 4. Let's get to it. So setting these equations equal to each other, we have x squared plus 1 over x plus 2 is equal to 3x minus 1. Right now, we might as well go ahead and say what the excluded values are. Alright, the only denominator I see is x plus 2. So therefore, x cannot equal negative 2. Keep this in mind. Can't divide by 0. Now, let's make the denominators the same. So, because of the x plus 2 here, I can make the denominators the same by putting x plus 2 here. Now, I can only do that if I also put x plus 2 in the numerator. Alright, now the denominators are the same. Once the denominators are the same, you can cancel them out. And you can make a new equation using the numerators. So I have x squared plus 1 equals, now I need to double distribute up here. So that's going to be 3x squared plus 6x. Alright, now I'm distributing the negative 1. So that'll be negative x minus 2. So let's see, x squared plus 1, 3x squared plus 5x, because 6x minus x is 5x. Bring down the minus 2. So let's bring these like terms together. So I'm going to subtract x squared from both sides and subtract 1 from both sides. So I have 0, 2x squared plus 5x minus 3. Now, maybe this is factorable. If it's not factorable, I will have to use the quadratic formula again. But let's see, 2x squared can only factor as 2x and x. 3 can only factor as 3 and 1. Now, it makes a difference whether you put the 3 here and the 1 here, or the other way around. I think this is the wrong place, but let me start with it in the wrong place to show you why it's wrong. Inner plus outer must equal middle. Inner, I have 3x. Outer, I have 2x. To make positive 5, both of these would need to be positive. That would mean that both of these would need to be positive. The problem is this last little thing. A positive times a positive is a positive, but this is a negative. So that is not working. So it was so close because we did get the middle, but we're getting the wrong sign on the negative 3 here. So it didn't work out. So the way to fix it is to reverse the 3 and the 1. Okay, so let's try putting the 1 here and the 3 here. Again, inner plus outer must equal middle. Inner, I have 1x. Outer, I have 6x. To make positive 5, I need a negative 1 and a positive 6. So negative here, positive here. This time, we have a negative times a positive is a negative for the negative 3. So that is working out. Okay, so that's factored properly. To get the solutions here, we need to set each one of these factors equal to 0. So this will give me 2x equals 1, x equals 1/2. And from this, I get x equals negative 3. Are either of these excluded? See, negative 2. No, these are both allowed. So far so good, but we're not finished yet. Can I get this all on the screen at one time? Not quite. So we need the y values that go with these x values. Alright, so I always like to make a t-chart out of it. So we have these two x values. We have 1/2 and we have negative 3. Okay, we need to find the y values that go with these x values. Easiest thing to do is to just pick one of these equations and use it to find the y values. I'm going to use this one. It seems simpler. Y equals 3x minus 1. Now you could do these by hand, or you could use a calculator. Just to make a point, I'm going to I'll do the bottom one by hand just to show you that I could. So y would equal 3 times x, which in this case is negative 3, minus 1. So that would give me negative 9 minus 1, which would give me negative 10. Alright, so negative 3 comma negative 10 should be one of my points. That's going to be a little bit more annoying with the 1/2. So that's a good time to show you how we could do it on the calculator. Let's see, 3x minus 1. So we go 3x minus 1. Make sure you're in Ask X mode. And we want to evaluate at 1/2. So I'll just do 1 over 2. Boom. Oh, look, 1/2 again is the y value. So it's 1/2 comma 1/2. While we're here, let's just verify and double check the negative 3. So if I put in my negative 3, there's the negative 10, same as we got by hand. Alright, so there it is, folks. So the final answer is 1/2 comma 1/2 and negative 3 comma negative 10. These are the solutions to the system.